All right, for today, I will discuss to you about using Avogadro's number in solving stoichiometry problems. So stoichiometry is the study of the amounts of substances consumed and produced in chemical reactions. So remember in Dalton's law, atoms are neither created nor destroyed during a chemical reaction. And mole, it is used to count atoms, ions, or molecules. So these parameters is what we call elementary entities. And 1 mole represents a very large number of elementary entities. So this very large number is what we called an Avogadro's number, which is equal to 6.022 times 10 to the power of 23. So it is important for us to remember this constant number because this is very helpful for us to arrive the correct answer later. So for example, if we have 1 mole of hydrogen, we'll be having 6.022 times 10 to the power of 23 hydrogen atoms. And 1 mole of water, we have 6.022 times 10 to the power of 23 water molecules. So we will say that Avogadro's number, H atoms, it is when represented by one element only. But if we say molecules, it is represented by more than one element. For example, here, H2O, okay? And 1 mole of hydride ions is equals to 6.022 times 10 to the 23 hydride ions. So we can say that 1 mole is equals to 6.022 times 10 to the power of 23 elementary entities. Therefore, we can say that we can use Avogadro's number in order for us to convert from mole to number of elementary entities. For example, mole to atoms, mole to molecules, ions, and formula units. So we will be having a discussion about converting from mole to number of atoms. So example number 1, how many atoms are there in 0.75 mole of copper? So we have a given here, which is 0.75 mole of copper. And the unknown is the number of atoms. So the unknown is number of copper atoms. And the Avogadro's number is 1 mole of copper is equals to 6.022 times 10 to the power of 23 atoms. So we used atoms because copper is represented by one single element only. So copper atoms is equals to 0.75 mole of copper. 0.75 mole of copper is given in the problem, multiplied by, so our denominator should be 1 mole copper because in order for us to cancel out these units, okay, then our numerator should be the 6.022 times 10 to the power of 23 atoms. Okay, so calculating 0.75 multiplied by this number, we will be having 4.5 times 10 to the power of 23 copper atoms. So we should be mindful about our significant figures since in this problem we have two significant figures, so 1, 2. So our arrived answer also should be in two significant figures also. So 1, 2. So 4.5 times 10 to the power of 23 copper atoms. Example number 2 is all about converting moles to molecules. So calculate the number of molecules in 0.350 mole of HCl. So we have a given here which is 0.350 mole of HCl. And our unknown is the number of molecules, okay? Then we use the Avogadro's number. So 1 mole of hydrochloric acid is equals to 6.022 times 10 to the power of 23 HCl molecules. So why we use molecules? Because HCl is a molecule. It is represented by more than one element. So molecules of HCl is equals to 0.350 mole of HCl. This is given in the problem. And multiplied by, okay, so we use the Avogadro's number. So 1 mole of HCl. So we should put 1 mole of HCl here. And the numerator is 6.022 times 10 to the 23 molecules of HCl. So we need to cancel these units. And calculating 0.350 times this value, it is equals to 2.11 times 10 to the power of 23 molecules of HCl. So our significant figures in the problem has 1, 2, and 3. So 0 is significant here. So we have 3 significant figures. So our arrived answer also should be in 3 significant figures also. So 1, 2, 3, 2.11. Okay. Example number 3 is about converting moles to molecules, then from molecules to atoms. So this is complicated, but I will guide you on how to answer this. So calculate the number of H atoms in 0.450 mole of glucose. So we have a given problem here, which is 0.450 mole of glucose, and our unknown is the number of hydrogen atoms. So the Avogadro's number that we should use is 1 mole of glucose is equals to 6.022 times 10 to the power of 23 glucose atoms. Okay? But we shouldn't use this value because glucose is a molecule. Okay? So we should use 1 mole of glucose is equals to 6.022 times 10 to the power of 23 glucose molecules. Alright? So remember, atoms is represented by a single element only. But glucose here has more than one element, so we should use molecules. Alright? And in order for us to convert from molecule to atoms, so one molecule of C6H12O6, this is the formula of glucose by the way, so is equals to 12 H atoms. So in the formula, we have 12 hydrogen atoms, so we need to put 12 here, okay? So let's solve the number of molecules of glucose. So molecules of glucose is equals to 0.450 mole of glucose. This is given in the problem, okay? Multiplied by 1 mole of glucose, then the numerator should be the number, the Avogadro's number. Molecules of glucose is equals to 2.7099 times 10 to the power of 23 molecules of glucose. So I put 4 decimal digits here because this is not our final answer. Remember that our unknown is the hydrogen atoms. So molecules of glucose is equals to 2.7099 times 10 to the power of 23 molecules of glucose. So we all know that 1 molecule of glucose is equals to 12 hydrogen atoms. So H atoms is equals to 2.1799 times 10 to the 23 molecules of glucose. So we will use this relationship. So 1 molecule in order for us to cancel. And the numerator should be the 12 H atoms. So H atoms is equals to 2.496 times 10 to the power of 24 hydrogen atoms, alright? But we can also solve just like this, alright? So 0.450 mole of glucose multiplied by this relationship, 1 mole of glucose, is equals to 6.022 times 10 to the power of 23 molecules of glucose. Then multiplied by 1 molecule of glucose is to 12 H atoms. So we need to cancel the units, okay? Just remember that we can cancel units from numerator and denominator, okay? So calculating, we have 2.496 times 10 to the power of 24 H atoms, okay? So I want you to answer this problem. So how many oxygen atoms are there in 1.50 mole of barium nitrate? So I want you to pause this video and solve in your own. All right, so we have number of oxygen atoms. So number of oxygen atoms, we have 150 mole of barium nitrate, this is the given. Multiplied by 1 mole of barium nitrate, we have 6.022 times 10 to the power of 23 molecules of barium nitrate. Multiplied by 1 molecule of barium nitrate is to 6 atoms. 6 oxygen atoms ni, by the way. So why 6 oxygen atoms? Because um, we have 3 subscript here and we have 2 subscript at the parentheses. So we need to multiply 3 times 2. So 3 times 2 equals to 6. So we have 6 oxygen atoms. So we need to cancel the units. So molecules of barium nitrate and molecules of barium nitrate, the denominator. So we left with 6 oxygen atoms. So O atoms is equals to 5.42 times 10 to the power of 24 O atoms.